Pleasure to meet you. Recording in progress. Okay, pleasure to meet you guys. As you probably already know, my name is Mike. I'm the co-founder and CTO of Algo Foundry. And so Algo Foundry is actually a venture studio in the Web3 space. And we'll get into that. So the agenda is right here. We're going to talk a little bit about the internet, Web3, the key features, and so on and so forth. And then we'll go into what is Algorand and then the apps that we've built on Algorand. Um, so this presentation was put together without much knowledge about what the domain expertise of everyone on this call is, right? So it's starting at the very basic and slowly moves up. If there's, hopefully we'll bring everyone along with us. But if there's everyone on the call is already very well versed in these topics, I can try to speed through some of these slides, but I'll just go through it and give me some feedback as we go, I guess. So, right, the internet, right? Everybody knows what it is. It's one of the things that I've talked about a lot in the talks that I've given, especially at NTU. Is It's one of the fastest adopted technologies ever in the history of humankind, only being outpaced by blockchain itself. And now I guess ChatGPT is doing a pretty good job as well. The first version of the web, I remember this quite well, being alive and active during this part of the world. But basically, the first version of the web was just a series of hyperlinks, right? You couldn't even put images and stuff. And the idea behind it is, you can make something look pretty and present static information. The Web 2, paradigm basically started in the 90s. And that was mostly an IPO dream, a lot of people chasing it. And this was the idea of Web 2.0 is just that the web pages now become interactive. They become real applications and they have real features and functions on them, mostly driven around JavaScript and related technologies. And then Web 3, which is where we are now, further introduces decentralization, identity, and a couple of other things, right? And we'll get, okay, only click it once. That previous slide is exactly a summary of the slide, so we didn't lose anything there. So basically what Web3 does is it gives you decentralization, and what decentralization really means is that content and people that are and actors that are acting within an application can be everywhere, and it's designed to be peer-to-peer more than it is designed to be basically server and client, right? Interoperability, the tenet of interoperability is that applications actually become Lego blocks in a way, or composable, and can be stacked and or interacted with in a way that the original designer of that composable piece didn't actually intend or plan for. The trust and security part of it of Web3 is really about creating a trustless environment, and it's actually quite interesting how humans think about things. When you actually get to a point where everything is trustless, it actually fosters more trust in the system than it does if you have to actually trust someone. It's a weird paradox actually, but the idea and tenet of Web3 being that since it's permissionless, anyone can interact. Since it's decentralized, anyone can act. The apps are designed in a way that you don't actually have to trust the other party. So those are the main things about Web3. Um, it it promises a lot of things. I think a lot of times people building the Web3 space actually have a tendency to have a solution and look for a problem. So it's not always the greatest application, or, give technology application for a given problem set. But the idea being that since it's decentralized, everybody's an actor. You can pretty much have control of your data. You can pretty much have control over your identity and what you want to share. You can encrypt the things you don't want to share. You can give partial access and so on and so forth. Um, in terms of innovation, one of the reasons why people think Web3 leads to a lot of innovation is that actually what it does is it lowers the entry cost for applications and startups to sort of start developing. In a traditional model, what would end up happening, and if you'll see this in all of the Web2 stuff, like if you think about the giants of the industry, like Facebook or Twitter or one of these, what you'll start to see is that they chase eyeballs. And so they oftentimes, these tech companies will oftentimes have business models that actually are not profitable. They have no way to monetize and make it profitable within the first 5 or 7 years. And the idea being that once they get to 1 billion users or 100 million users, that they'll find a way to make it monetizable at that point. But that kind of business model requires a lot of capital. And typically that's because uh, all of the risk is put onto the actual business itself. So, for example, if you're building in Web2, you would have to pay for your server costs, you would have to pay for your development, you would have to pay for your maintenance and running of your application, and then you would be taking the risk on that capital and that payment and that maintenance and all the salaries and everything goes into it. Then you hope to make it back, right? In the Web3 model, since things are decentralized and peer-to-peer more, typically what you'll see is people will build things in terms of smart contracts and using sort of this public infrastructure like a blockchain, a public blockchain. And typically what will happen is the costs will be passed back to the user right from the beginning. So instead of paying a big AWS bill and running and maintaining your database and having to do backups and disaster recovery and all this kind of stuff, you'd write the smart contract, launch it, and then when people want to interact, they're just paying a very small, well, in Ethereum, it's not that small sometimes, but they're paying a transaction fee, a gas fee, a network fee on every transaction, which basically covers those same costs. So it's democratizing in a way or decentralizing in a way the cost basis for startups. So this actually tends to lead to less hurdles and less friction and more innovation. And then transparency, because even though it's encrypted, in the sense that you proving your identity with a private key, that you can encrypt something that other people can basically encrypt and you can decrypt. The blockchains are basically immutable and transparent and access to anybody, right? So every transaction that's out there, every transaction that ever happens on the blockchain can be downloaded, can be analyzed. It's very hard to hide. So where Web3 is mostly made inroads so far is, I would say, probably 90 or 85% in the finance sector. Most of it's around decentralized finance. It might be around GameFi. It might be around other things that are related to currency trading and finance in some way. There have been some interesting projects that are out there that are doing things on social networks. Not that much traction. There's some interesting things around storage, IoT devices, that's around supply chain and so on. And there are projects that are getting a lot of traction, a lot of adoption and users, but it's pretty much not the thing people think of when you think of Web3, right? That's because finance is dominating the sector at the moment. Okay, so it's not all rainbows and puppies and butterflies and so on. There are challenges when it comes to this technology. One of the biggest challenges is actually adoption, and mostly that is because of several factors. The first factor is the FUD that's out there, that continuously, a non-ending barrage comes from all kinds of states, government agencies and so on, regarding, crypto is only used by people who want to hide something. It's only used by criminals. It's, this is a constant thing. There's also uncertainty when it comes to regulation. It's a asset class that is hard to regulate because it's a lot of the crypto applications actually don't fall very cleanly into the traditional finance and traditional regulations. So, is it a fund manager, or is it a digital custody, or is it a payment solution? Who knows, right? These are all three different licenses in Singapore. Some applications have a little component of all of those. So because of that FUD, it does drive it does have a chilling effect. The other things that hurt adoption specifically in Web3 is the user experience is not great. The reason for that is they're trying to sort of drive a self custody or self management of your identity, of your keys, and your ability to sign things. And every application, everything that's out there in Web3 sort of does it a different way. Sometimes two applications rely on each other, so you have to go to application one to do something and take the results and go to application two and do something else. There's not a very unified view of it, and so on. So the user experience is also hurting adoption in a lot of ways. Scalability is an interesting one. A lot of people talk about scalability in blockchain specifically, and they'll tout numbers. They'll say, oh, you know what, Solana is amazing. It can do 48,000 transactions per second. It's so awesome. But if you actually look at the number of transactions throughput on every blockchain, they have a report they put out every month. They detail the actual number of transactions that every blockchain has done. You will see that it's not that amazing. it's far from amazing. There are a couple that are exceptions. Algorand is one of those. That's an exception to this rule. It actually is capable of doing the 6,000 transactions per second. But for example, if you look at L2 networks out there that are like Optimism or I don't know, you name the one you like, Arbitrum or Polygon or whatever you like, that were built specifically to scale Ethereum, you'll actually see that the number of transactions per second is not that great over Ethereum. Like they're promising they can do hundreds or thousands of transactions per second, but in reality, they're doing like 23 and Ethereum's doing 17, right? So scalability is actually quite a limiting factor in a lot of ways. And then interoperability is actually also been quite difficult. There's three different types of, or three major, I'd say, camps of blockchain or Web3 networks, right? So the first is Ethereum, the EVM. That's obviously the original. A lot of people have copied it. A lot of people are using technology very similar to it. There's, it uses tooling and everything is around Solidity, as you probably already know, and Viper maybe as an alternative. There is the Rust-based packages. So there you have Solana, you have Near, Cosmos, and the newer guys on the block that are using Move, which is very similar to Rust, like Sui or Aptos. And then you basically have the other bucket, which is other, right? And that's where Algorand fits in, and this EOS, and to some extent Tron, even though it's kind of EVM based, Polkadot, some of those things, some of the substrates there are not EVM based. So these are the major things, right? The major technology stacks that are being used, and you'll find that the interoperability between different blockchains is actually quite limited when you go between these different types of technology stacks. It's not that easy of a problem to solve. And so that's another hurdle or limitation. So I've said Algorand is one of the blockchains that is actually delivering on its promises. A little introduction to Algorand. It's relatively new, in terms of Bitcoin or something like this is much newer than Bitcoin. It's really hit mainnet in 2019. It's invented by this guy over here that you see. His name is Silvio. He's a professor at MIT, one of the world's leading experts in cryptography. Um, they've they've designed a thing called pure proof of stake, which is um, pretty good for consensus. Makes it very difficult to fork. When they would say impossible to fork as a blockchain. Nothing's impossible in my view, but okay, as close to impossible as possible. It has some very advanced features on the layer one that other blockchains don't have. It's built for scalability. Obviously, it has finality instantly. So as soon as a block hits the blockchain, it's final, which is a deviation from most blockchains. So it has finality in 3.5 seconds, which is pretty amazing. It has things like proof of stake built in. You can use the blockchain to derive real randomness. It uses cryptography, which is quantum computing proof, and so on and so forth. Right? Pretty amazing. I did click it. Now I'm not sure. Okay, there you go. All right. So, how does it work? Well, I mean, basically, it works very similarly to Ethereum in the sense that it runs on a virtual machine. And the virtual machine, what that basically means is it's running a sort of, you can think of it like a computer, a processor, CPU, kind of running in the cloud. Every one of the nodes is running a piece of software which can process things almost like a CPU would. In theory, you can use different languages to compile down to this virtual machine. At the moment, the bindings that are used in the community are all around Python. So there's one called PyTeal. There's another one called Beaker, which is just using the class-based Python stuff. But in theory, you could write a language to do this. This is what Solidity is. If most people know Ethereum well, so I just talk about it in comparison to Ethereum. But for example, Ethereum also runs a virtual machine. It's called EVM. And it has a Solidity as a main language called, which is compiled with Soul Seed. It has another language called Viper, which is very similar. It compiles down into opcodes, which are in an assembly, which is just a stack-based language. So you push and pop things from a stack and compare them. AVM does the same thing, but it has real constraints in Algorand. That's how they achieve their transactions per second and their finality so easily. The constraints are around storage in particular, and some other things in terms of how the language does forking and conditions. So it's not as straightforward to build on Algorand. That's one of the limitations. Smart contracts, pretty much, they drive Web3 on the back end. You can think of a smart contract in its simplest form as just a series of conditional things that get checked in order to approve or deny a transaction, although that's not always true. The state changes as well. They're basically one of the limitations of smart contracts is that it's pretty much immutable, like every transaction. So if you actually compile your application and you put it out on the blockchain, what you will find is that application code actually never goes away and doesn't change. The upgrade function for that is typically just to put a new version, which is now a completely new entity, and point everything to this new address. So that's a little bit of a difference between normal code and smart contracts. But typically, this is used for everything from tokens, which are actual currencies, to NFTs, which are like single versions of a token that can't be changed. It's used for state storage. It's used for pretty much everything, actually. The smart contracts on Algorand specifically are a little bit different. So there's actually two different types. There's a stateless smart contract, and there's a stateful smart contract. So in the sense of comparing it to Ethereum smart contracts are all stateful. That means that they're saving state on the blockchain. The stateless contracts in Algorand give you the ability to do crazy things in the sense that it's the only layer one chain that's capable of these things, built into the actual protocol. And so what you can do with a stateless contract is you can actually create these sort of rule-based, permission-based signatures. So for example, let's say I wanted to transfer 100 algos from my wallet to a vendor every day, every first of the month, right? What I can do is I can create a stateless smart contract, which has the rule base for that transfer, and I can compile it and sign it with my own key and give that to the vendor. And the vendor could then use this to sign a transaction which moves those 100 algos, and it would only approve it if it met the conditions in the stateless contract. But that state is not saved on the blockchain, it's actual key. So most layer ones don't have that kind of thing. But basically what ends up happening is every block, every signed transaction, whether you are transferring a token between two people or the native token, or you calling a smart contract, updating a state, every single one of those things goes into every block and it's saved forever, right? It's immutable. Here are some of the things that are built on Algorand in general. Just as a comparison to other chains, Tinyman is a DEX, a AMM DEX, so that you can do swaps between different tokens. AlgoFi is a major lending protocol, so you can basically deposit an algo and lend USDC or whatever the case may be. Lofty is basically a real world asset application, so it's specifically in real estate in the United States, and it allows people to sort of crowdsource buying of real estate and making a sort of return on rental and so on. And Dartram, actually, to be honest, I'm not sure what that is. I will look that up after this presentation. I should probably know that. Algo Foundry, okay, that's basically the venture studio that we're running here. So just to qualify it, what is a venture studio? A lot of people don't really define it the same way that we do, or maybe it's a very vague term. Venture studios really start at the beginning of a project at the idea phase. Before anything, it's just 2 people or 5 people in a room saying, hey, wouldn't it be cool if we had XYZ, right? So it's really at that very, very early starting point where it's just an idea on the back of a napkin. And then there are and that we call that phase ideation, right? So you're usually going to do a lot of things there, like validating your idea, talking to a bunch of people, making sure doing competitive analysis, understanding the industry size, and so on and so forth. And once you move out of ideation, then you get into a phase called incubation. And typically what happens in an incubation phase or an incubator is you take this idea and you build a business case around it. You do projections, you build a deck, you polish a story, you find, a founding team, and you pretty much get yourself to the point where someone might actually give you money to try and build this. And then basically after that comes an acceleration phase. That's what accelerators do. They take this idea that you might have gotten money for, and they actually help you, or in this phase, you basically build what's called an MVP, or not really a proof of concept anymore, but a minimal viable first product that can actually go out there and live and get adopted by the user base. And the final stage of a business is what they call growth or scaling. That's where you actually grow your users and your revenue and make a viable business out of it. So a venture studio actually encompasses all four of those phases. We don't only do the incubation or acceleration, right? We go right from the idea all the way through scaling. So just so you understand the background, there's actually a venture studio called Undercurrent Capital, Undercurrent Technologies. I'm also the co-founder and CTO of that. That is exactly the same thing as Algo Foundry, except for it is chain agnostic, whereas Algo Foundry is this exact same setup, just focused primarily on Algorand, and it's also jointly owned by the Algorand Foundation. Some of the products that we've put out in the last just over a year that we've been operating Algo Foundry is, we'll go through these individually, but the Foundry Safe is one of them. It's a account abstraction product. It's basically a smart contract wallet, which allows you to use it as multi-sig, enforce different rules, and abstract your account. So what I mean by abstraction is you can have a wallet that's in your browser on your phone that's controlling the smart contract wallet, and then you can switch that to a different wallet and update it in the smart contract, and all your funds are in the smart contract basically. So you don't have to, I mean, obviously you have to make sure you have access and control, but it's not necessarily the wallet on your phone. So like if you get, hacked or whatever, phished or whatever at a public hotspot or something like that, no one's taking your funds, right? Algorand Finance is another product we put out. It's a derivatives market. It's actually what's called the DOV, or Decentralized Options Vault, in the industry. It basically sells derivatives on crypto in specific ways that allow you to get a yield. And it's quite innovative in a way. It's one of the only products on DeFi that doesn't rely on weird tokenomics or Ponzonomics in order to profit. It's very clear where the profit and yield comes from. We'll go through it a little bit. Messina is a cross-chain liquidity protocol, or some people think it's a bridge, call that a bridge. Some bridges don't work exactly that way. But basically it connects Algorand to Ethereum, Kronos, and Polygon. It allows you to bridge NFTs and tokens between those chains. And we also have an oracle that we've built for Algorand that we do use internally, but is not released as a product at this point. Okay, what is the safe? Amazing. So if you have ever been on Ethereum, you might know a project called Gnosis. Gnosis Safe, but basically what it does is it's you can launch what's called a safe. This safe is a smart contract. You can have as many, I think there is a theoretical limit, might be 20 in this case, but you can have up to, let's say, 20 different people, different private keys as signers or owners. You can set how many have to sign every transaction. You can set different workflows and so on and so forth. When you create this safe, then you would transfer your assets into the safe, and every transaction from that point on would have to then also be agreed by the other people, just like a multi-sig. But this abstraction allows you basically to, as I said, to not to be too concerned about using a hot wallet to control it, because obviously, let's say there's 5 people on your safe, an attacker could get all 5 people's wallets. It's possible, but it's a lot safer than potentially using your mobile phone as a wallet, or even worse, using a centralized exchange like Coinbase or something like this as your mobile wallet, right? So this is one of the products. We can, well, there's a Q&A, so if you have any questions specifically about it, I'm happy to talk about it. Algorand Foundation, as I said, is a derivatives marketplace, and it's actually quite interesting, this product, because the one thing that that we always say, or at least I say it a lot, and I have this T-shirt actually. It's basically the saying is this: if you don't know in DeFi, right? If you don't know where the yield comes from, you are the yield, right? And so what I mean by that actually is that a lot of people in DeFi will actually give you returns out of thin air. They'll say, hey, put your ETH or put your algo into this vault, and we'll give you 1,000% return, and we're going to give it to you in Jimmy Bob tokens. And don't worry, Jimmy Bob tokens are amazing. And you get all these Jimmy Bob tokens, and then what ends up happening is there's no liquidity for it. You can't ever get out of it, or if there is liquidity, you get a permanent loss on the trade. So you basically just you go to zero over time. They just bleed it out, right? Another way that DeFi often works is through a sort of a Ponzonomic scheme where they kind of the project makes money by growing the user base and paying the original depositors from the incoming users. And so outside of those things, and that's in crypto and DeFi, that's rife. There's more projects that do weird things like this that are basically scamming you than there are projects that don't in reality, right? You just have to go look, I guess. When it comes to stuff that really does work and is not a scam, something like a Uniswap or a AMM DEX where you're providing liquidity, or a lend borrow protocol like Aave or something like this, typically what you'll find there is you at high risk for what's called impermanent loss. So you would maybe put in ETH or Algo and USDC, and as the price fluctuates away from the point where you actually made the investment, doesn't matter if it goes up or down, you're basically losing money, right? And the trading fees won't make up for it. And so there's a lot of strategies about how to negate that, but this is the real problem with DeFi. So what we did here with Algorand is made it very simple. Right? If you deposit Algo in this case, you get paid in Algo. If you deposit USDC, you get paid in USDC. There's no crazy token. There's no impermanent loss. Where do the yields come from? It's very simple. There are people that are sitting on tokens that they care about it going up or down. They don't want to lose money, and they're willing to pay a very small amount of money to ensure their position. They do that through options. That small amount of money that they pay to sort of ensure their position is the yield for the vault. So it's very simple. You understand where the yields are coming from. And this is one of the only applications on DeFi where, it's laid out that way. As I said, Messina cross-chain protocol. So exciting thing about Messina is that not only is it token bridges exist, but it has a liquidity pool model. So it doesn't do wrapping of tokens. If you move, for example, USDC from Ethereum into Algorand, you get USDC on Algorand. If you move, wrapped ETH, you get wrapped ETH, right? There's no like, it's a one-to-one mapping of value. That's one thing. We also are working on an NFT bridge at the moment, which got a couple of innovative features, which, for example, it doesn't just lock and sort of give you a copy of an NFT on another chain. It will actually destroy the NFT on the source chain and give you the actual NFT on the other chains. There's only one copy of the NFT on any chain. That's one of the standards that we're implementing. We're also doing stuff around rentable NFTs and so on and so forth. We can get into that in QA if you guys are curious about how that works. Another big component of the actual Venture Studio, the final piece, is the actual education piece. So we actually have a curriculum that teaches how to be a developer on Algorand. And yeah, we've put about, I think, 150 people now, somewhere around there, through these courses. It's adopted as official curriculum in a couple of universities. One of them is in Morocco. We're actually talking to NTU about putting it into the master's program there as well, here in Singapore. The idea being that you get a professional certification on top of what other education you might have. yeah, you should check that out if you're interested in being a blockchain dev. And yeah, and that's it. And then we get to the Q&A.
Great. Thank you so much, Mike. That was really interesting. I think there are a couple of questions that a few of us have. I think I'll just get the ball rolling. Just want to pick your brains a little bit. So when you look at the future of Web3 and blockchain, right, do you see it as a one chain rules them all sort of solution, or what do you this is your perspective on that?
No, actually, I don't. I might be in the minority. I don't think so. I think I was in the minority a year ago, and now it's becoming, my opinion is becoming more popular in the mainstream. I actually I think that generally speaking, technology follows an adoption curve. And in the beginning of a technology, the pioneers kind of group together, right? And they try and create these camps. And then you're either in one camp or the other, and there's some safety in numbers. But at the end of the day, what ends up happening is people start to splinter, and they stop doing that kind of thing. So my question to you back, if it's one blockchain rules all, would be, what would be the advantage or benefit of being on Ethereum or being on Polygon or being on Bitcoin or being on Algorand? What is the advantage of it, right? And when people typically face that question, they would say, well, there's user communities. Well, okay, that may be true, but so you're basically talking about discoverability of an application. Typically, if you have a strong use case and you develop an application that has a strong use case for adoption, you don't need to rely on a networks community in order to drive adoption. So just if you think about it, let's imagine someone was going to build a new application for Windows, right? Do they really need like some random group of like 40,000 Twitter followers to be able to tweet to? And if they don't have that, they can't get their sales on their Windows application. Doesn't really work like that in the real world, right? It only works like that in blockchain now. So I actually think that the future of blockchain is that every application that has a strong use case will launch their own chain, and interoperability tools between the chains will be stronger, and will be so easy to use and seamless that you won't even know that these applications are using blockchain in the background, and you won't care.
Yeah, thanks for that. I think I think just to build up on that point, I think right now, even the state of DeFi, I think things can be quite confusing for new users as well. Like when you look at various applications, right? There are like so many different blockchains that are out there. So you don't even know what wallet to use or what chain. So I think that kind of hinders the progress of adoption in one way. So moving forward, I think what we should be seeing is, like these layers become hidden in a way, such that users are very easily onboarded, and then they really focus on the application rather than end of it, right? Which is what's really important.
Yeah, exactly. Yeah, I mean, in the early days, what ended up happening was like, okay, I have MetaMask, I have Ethereum, so what applications are there that I can use, right? And really what it will turn out to be is, hey, I have this way to access this new world, and what applications are there? It doesn't matter what blockchain they're on, because like this application will just connect me wherever, right?
Yeah, definitely. Before I ask my next question, does anyone else have any questions they'd like to ask? Feel free to shoot if you guys have any queries. I think it was quite interesting what you shared on. So
I had a question. Earlier you mentioned about how you're able to bridge tokens across without wrapping them. I was kind of curious about how that worked exactly.
Yeah, sure. So basically, there's really two models to bridging. The first model is called wrapping, or what they call, I guess the official name is mint and burn, right? And so basically how it works is, let's say you have a bridge on Ethereum, and you're bridging to Algorand for this example, right? And let's say it's ETH. You have ETH on Ethereum and you want ETH on Algorand. Well, what will end up happening is a bridge will have this smart contract which will actually create these wrapped ETH on Algorand, And when you bridge it over, you'll lock your ETH on the Ethereum side in escrow, and on the other side, they will mint this new wrapped ETH and release it into your Algorand wallet, right? And that model really only works for one use case, which is if you've got a very particular protocol that wants to be multi-chain. For example, if I created I like saying this because it doesn't exist. If I create an application called Jimmy Bob's, and I create Jimmy Bob token, and I would now suddenly want to be on AVAX, cool. People can then take my Jimmy Bob of Kronos or Ethereum, and they can move it on to AVAX. That works for me in that use case, right? But it doesn't work at all for what they call value tokens, or tokens that exist already on blockchains. For example, USDC. So USDC exists in, I think they have 7 or 9 or something like this, different blockchains they support in terms of Circle. And so if you take USDC from ETH and you send it to the bridge in the same way, you're going to get what's called a wrapped USDC on Algo. And then what are you going to do with that wrapped USDC? Somebody would then have to create liquidity on a DEX and allow you to trade wrapped USDC for real USDC, right? The way that we get around that is using the alternative model, which is called a liquidity pool model. And how liquidity pools work is we maintain some liquidity on ETH, on Ethereum for USDC, and we also maintain liquidity on Algorand for USDC. So when you want to move USDC from Ethereum to Algorand, you lock it, you add it to the liquidity pool, actually, and then it's released from the liquidity pool on the other side. So it's just a mapping of tokens. So this has no wrapping effect. And so this same mechanism, so it solves that problem. And then when it comes to projects like Jimmy Bob, it also works, because what will end up happening is, let's go with the same example. Let's say I have Jimmy Bob tokens on Ethereum. I want it now on AVAX. Me as a project, what I will do is I'll go onto AVAX and I'll mint my Jimmy Bob tokens, and then I'll put them in a liquidity pool. So, and then map them, right? And so then when people want to go from Ethereum to AVAX, it's just adding a liquidity pool and removing on the other side. So you get both use cases with a liquidity pool model. You only get one with a wrap. So.
Okay.
Yeah, I think I'd just like to build on that actually. So looking at the first model versus the second model, like the wrap model versus the LP model, right? Is it fair to say that the LP model is in a way safer in terms of the chances of a DPEG happening between the wrapped version of the token and the non-wrapped version of the token?
Well, to be honest with you, security is, they have a different attack surface. I wouldn't say it's safer. When it comes to wrapping, the attack surface is to basically make an attack on the wrapped, on the what they call the target chains, such that you basically get wrapped tokens that you should never have gotten. And then you basically bridge it back into the source chain, and you get real tokens that you should never have gotten because you're bridging wrapped tokens. So basically what they call that security model is sort of a strong wall model, right? Once you breach the outer wall, the inside is not protected, right? When it comes to the LP side, it has a different attack surface in the sense that let's say there's something wrong with the escrow contract in some way, or somebody's not careful with the admin keys or whatever the case is, it might be possible to drain one of those pools, or if there's a case of a escrow contract, exploit all the pools on one side of the bridge, but it's only going to affect one chain, because that same exploit will not be present on Algorand, for example, or Aptos, or whatever the case is. So it's different attack surfaces. What we do to prevent that, just so you know, in Messina's case, is we work with a company called Kudelski Security, which is a publicly listed company out of Switzerland. They've been in cybersecurity for a long time, since the late 1960s. And they've created a product with us called Impulse. And what that product does is it actually monitors the blockchain in real time for attack or what they call threat assessments. They call them TARAs. It monitors the blockchain on all chains for the bridges contracts, and it looks for what's called unexpected, and invariant behaviors. And when it detects something is going on, basically on the same block that it occurs, we have built into the contracts what they call countermeasures. So the countermeasures might be pausing that token, rate limiting that token, lowering the the per transaction amount for a token. For, let's say it's $5,000 max transaction, we could lower it to 100 or something, $100 or something like this. We could whitelist, blacklist wallets, and we can do that in real time as it's detecting threats. So that's basically how we go about protecting the bridge.
Yeah, that sounds cool. Yeah, I think this idea of Messina is actually quite interesting. So I was wondering, where the LP model, right, where you basically are putting your funds into an LP and pulling it out again from one blockchain to another blockchain. Is it possible for users to earn yield from this by depositing the assets on both sides?
Yeah, so it is generally there. This model is used in a couple of places. Stargate is the biggest one. They're built on top of layer 0. There's another one called Synapse where you can also do the same thing. And I think multi-chain as well, which is one of the bigger bridges, has this model. With Messina itself, right now, we don't allow that. That is something that will be rolled into Messina in the end of Q2, when we come out with our tokenomics model. So there'll be a token associated with Messina that will sort of reward you with bridging fees and stuff like this, and allow you to do governance, and as well as allow staking of coins into a pool. And one of the reasons why we want to do that with Messina specifically is that there are problems with liquidity in DeFi, right? So liquidity is mercenary, but it's also very underutilized in DeFi. In a lot of cases, you put your liquidity in there, let's say in the DEX, it's $10 million sitting there, but there's only $1 million a day, right, being traded. So if that's happening, like 90% of the liquidity is actually not doing anything. In this case, well, I mean, it's being shared obviously on fees, but it's not really doing anything. So in this case with Messina, we plan to add like other use cases, like the ability to lend out your tokens to market makers and stuff like that, and have very high-end risk management to control that. So it's not just useless liquidity, but that's coming later in the year.
All right, great. I think I'll just anyone has one more question they'd like to ask Mike before we let him go. I think it's been a while, but yeah, it's been really interesting sharing, Mike. So does anyone else have anything to ask? If not, I just got one last question. I just wanted to get your opinions on regulation, right? Like, where do you see it going in like the crypto space moving forward?
Yeah. Look, I mean, this is an interesting one, actually. It's as you probably understand, regulations are actually happening in real time right now, right? And Singapore has taken, like, this part of the world, Singapore in particular, and then Southeast Asia that's not Indonesia, have taken sort of the approach that crypto is fund management. That's what it is. It's digital assets, fund management. You get a fund management license, you're pretty much covered. If you are regulated, in other words, if you're doing running a bank, a brokerage, insurance company, or if you have like a PSA, which is like a money changer license, typically you shouldn't touch crypto. And if you do, it's got to only be in derivatives. That's typically what this area of the world has done. The United States, which is unfortunately the 300-pound gorilla in the room here, is taking another approach, which is they're actually going right now after what they call silent quitting. Have you ever heard of silent quitting? That's kind of like when you're an employee and you hate your job and you want to quit, but instead of quitting, you just show up every day and don't do any work and get paid anyway. They're basically taking that approach to crypto regulation. So instead of passing regulation and changing and adding this, which is a lot of work, by the way, adding a digital asset that they fully have to understand, and all this kind of, no, they're like, oh, it's too much work. So what they're doing instead is they're just basically putting pressure on banks and saying to them, hey, stop taking crypto money. And that's already having a huge effect in the United States. There was a bank called Stargate, actually, that just went under. There were two banks that did international settlements, so Stargate and then Signet. And then basically what these banks did is like, okay, let's say you were an institution that did crypto, you want to cash out. I want to pay some other guy in Germany, I want to pay another person in South America, whatever the case is, I can hit a button. And if I have accounts in one of these two banks, they get their funds like instantly, anywhere in the world, right? So one of those banks is now dead. There's only one left. And that's due to the US putting pressure on that bank not to take crypto funds. So they basically not renewing banking licenses. They're setting their the fractional rate that they have to sort of fund their banks for if they take crypto that are much higher, and they don't give them favorable terms and so on. So basically it's very, very hard these days, and it's going to get much harder for people to actually do anything in crypto. And instead of regulating, they just basically choke it to death. That's what's happening right now.
Yeah, I think that's a very fair point. It's really sad, right, to see the shutdown of Silvergate, and I think it's going to be really hard for users from now on. But
Yeah,
we'll see how things go. But yeah, thank you, Mike, for your time.
Yeah. Sure.
We've got a presentation lined up for participants of a hackathon after this, but before we let you off, I would like to take a quick picture with all the participants. So I just get you guys to turn on your cameras.
Oh, we're gonna do it together. Okay.
Yeah. Okay,
Amazing.
great. All right, just give a minute for everyone to turn on their cameras. Okay. If not, okay, we'll take it in 3, 2, 1. Great. Thank you, everyone. Thank you, Mike, for your time. I think that was a great sharing, really interesting. Yeah.
Appreciate it, guys.
All right. Thank you, Mike.
Yep. Have a good night.
Thank you.
Good night. Okay, for those who are still here, we actually have a quick sharing on the Block Bash Hackathon for those of you who have signed up. For those of you who haven't signed up, feel free to sign up. Sign-ups close next week on Monday. So we've got really interesting things lined up for everyone. So I think Han, you can take it away.
Sure. Can you see my screen?
Yep.
Okay, sure. Okay, thanks everyone. We're very pleased to see you here for the briefing about Block Bash Hackathon. And this is the very exciting semester events that BNS are going to bring to you for this semester. And hopefully you will have a very careful and solid journey with us. Here are the things that I'm going to cover in this briefing. Okay, so the first is, what is Block Bash Hackathon? So you will remember that last semester we have a research project competition for the participants to know the existing blockchain projects and to have some critical views about them. And for this semester, we are going to bring it to a higher level where you will be propose your own innovative ideas about to build a prototype of your own blockchain project. And lastly, you are going to have a presentation about your ideas and your prototype, and you will get help from our profs and some experts from the industry. So in summary, the participants will be going through 4 weeks of preparation and finally have a presentation about their ideas and the prototype. Here are the things that you're going to expect for this hackathon. The first one is hands-on development experience. And for this semester's events, we are going to build the prototype using PTO in Algo chain. And also you have a chance to showcase your idea in front of a panel of experts as our judges. And if you currently want to find some like many peers but you don't, so this is also a great chance for you to sign up and to get some friends which have the same interest as you. And there are some supporting resources through this hackathon, like the previously recorded workshops by Algorand, and some documentations in the PTO development, and the Algo Hub is bring a curriculum with 4 PTO workshops for the beginners who are not so familiar with PTO development. And they are providing technical support if you have questions during the development. And there are few very exciting things that you are going to expect. That you got the chances to get the PTO certificates by Algorand, because this PTO courses is very similar to their original courses, and they are providing the certificates for this. Also, you are going to show your idea in front of the industrial experts, and if they are very interested in your project, you will get a chance to proceed it further as a startup. And this is the timeline for this hackathon. The close of the registration will be next Monday. And at the same day, the first workshop of PTO will be carried out by Algorand. And the whole 4 workshops will be carried out within the first 2 weeks, and then followed by the pitching trial in week 11 and the grand final in week 12. Also, it's very exciting that we have a very generous prize size for our participants. And we have 2,000 for the champion, 1,500 for the first runner-up, and 1,000 for the second runner-up. And if you are quite interested in this hackathon, you can sign up through the link. And this sign up information is already posted in our Telegram channel, so you can refer to it anytime. And for the targeted participants, it's to all NTU students. And you can sign up with your teammates or individually. And if you do not have enough teammates, we will be assigning you teammates. And for the pre-requests, there's no specific pre-skills needed, because we will have the workshops to teach you how to build your prototype in PTO. But the programming in Python will be helpful for this development. Also, this semester we are going to send out our announcements about this event and all the management in the Discord server. So if you haven't joined our server, please join this server. So you will be receiving announcements and be added to the specific group. So you will be get in touch with us closely. So that's all for this hackathon. Hope to see you in this in later events in our workshops. Thank you.
Yeah, thank you so much, Han. So don't worry about the links. I think everything we sent to you guys on Sunday night when we finalize the number of participants in the hackathon. But for now, I'd like to thank everyone for taking a time off to come down despite all your busy schedules. And yeah, it's gonna be an exciting half a sem ahead. We've got a couple of interesting events lined up. So yeah, I'm looking forward to interacting more with you guys. Other than that, thank you so much and have a good night, everyone.
Thank you. Have a good night.